I mean, not that Megan's not an exciting person, right? Look how distracted they are. Okay. Shut up and listen about the universe. Laugh. Laugh. Okay, so the universe now is transparent. Light can travel freely, right? Eventually here it's radiation. Most of the energy of the universe is in radiation. After this point, sometime in here, okay, the radiation's all been stretched out. It's got nothing left, right? It's basically the radiation given off by a very, very cold object, okay? And so most of the energy of the universe now is in the matter that was left after the condensation events, right? Okay, let's go back to the ranch. 2 or 3 minutes after the Big Bang, you can figure out where that is on your little timeline, right? Okay, but it's after leptons condensed out, before the photon decoupling, somewhere in there, right? Fusion starts to occur, right? So protons start joining up with other protons, neutrons and protons get together. What can you make now? Well, let's look at what you can make. You can make what? You got protons and neutrons, right? Well, you could get a proton. Proton could run up to another proton. Is there any stable nucleus with 2 protons and nothing else? No, there's not. Boom, it annihilates. It flies apart. Okay? How about a proton and just a proton? Is that a stable nucleus? Yeah, that's stable. How about a proton and a neutron? Is that stable? Yeah, that's a deuterium nucleus. That's a stable nucleus, right? How about a proton and 2 neutrons? Is that stable? Yeah, how about a proton and 3? No, that's not right. How about a proton and a neutron and a proton and a neutron? Is that stable? Yeah, that's a helium nucleus, isn't it? Yeah, there we go. How about, are there any 5s out there? Are there any nuclei with 5? Nope. Let's just take a look. Let's look at it. These are stable. The colored ones are stable. White ones are unstable. They fly apart as soon as you make them, right? So 1 is stable. 1, 2, 3 is stable. 3 and 4 are stable. The next stable nucleus is, bad news, 6. Big Bang, this is called, let's all say this out loud, Big Bang nucleosynthesis. The making of nuclei by the Big Bang. Big Bang nucleosynthesis stops at 5. There's no stable nucleus, and this is kind of a weird thing. Wouldn't you think if you created a universe, you'd make a stable nucleus with 5? No. Perfect conditions for fusion, by the way, but there's no stable nucleus with a 5. Now let's imagine that you bridge that gap. Okay? In a most unlikely event, simultaneously, a proton comes in, has to happen simultaneously. I don't know how simultaneously or not, but let's suppose that a proton and neutron come in at exactly the same time. Not very likely, correct? But they do. And you bridge that gap. Well, now, baby, you're good. You've got 6, you can go to 7. That's pretty hopeful, isn't it? 6, you could grab a neutron. That's easy. Just grab a neutron. Hey, we got 7, right? Game over. Is there an 8? No. No, there's no stable 8. There's no stable 8. Isn't that sad? So they believe that maybe some lithium was made. Maybe some things bridged that gap. But even then, these things would be fairly unlikely. And then what's the likelihood that another very unlikely event would happen? Well, probability times probability is like, gee, not very much, right? Okay. Now, how do we know this stuff? We know this really well. Okay. We know that Big Bang nucleosynthesis theory, we've got this down. We know what happens at high energetic nuclear fusion reactions. We've got them down. Why? Because we wanted to study the origins of the universe, or because we wanted to kill Soviets?
Kill the Soviets.
Kill the Soviets wins every time, right? Military budgets are always much bigger than the research of private institutions, right? So we've got really good models of this, and it's all people that work, for the dark side of physics, right, that did this. Now, think about this. Think about this, guys. We're almost done. Okay? 75% of the matter is hydrogen, 25% helium. Is that because there is hydrogen, deuterium, tritium, right? And then you have helium. Is it that helium is just 1/4 of the things? Yeah, that's what it is. It's just there it is, right? Okay. So if you look into space, if you look far away from stars, and you just look into space and take a spectrum of what's out there, you can do this, right? It all radiates a little bit of energy. This is exactly what we see. 75% of everything out there is hydrogen. 1/4 of it is helium. So now you can have any theory you want, but it's got to have showed that the universe was once small, was Heisenbergly uncertain, emerged from a big fiery explosion, had spherical harmonics of an emerging four-dimensional sphere, okay, and had situations that created a big fiery hot fusion furnace that created these elements in exactly those proportions. The Big Bang does that. Nothing else does this, right? So there's there's problems. We've got like calculational things and gaps or something like that. But nobody's saying that it's Chris Murrayism, which is sad. Okay, although I think my theory predicts the evidence exactly. So, okay, and then there's all sorts of things. You can look far away. If you look at distant stars should have few heavy elements because stars make heavy elements. Correct? To begin with, there were just stars. There wasn't the remnants of stars, right? So if we look at real primeval stars, they should have very few heavy elements. And of course, this is what we see. If you look at stars really, really far away, ones that are really like the first stars ever born, they have no uranium, none of that stuff is in anywhere near those stars because it wasn't made yet, right? Stars make them, and stars take a long time, 1 billion years or something like that, millions of years, right? Okay. And of course, this is another example of the universe changing over time. All right? Yay. Go team. Isn't that beautiful?
Yeah.
All right.
What's going on with that neon 20?
The neon 22 there is half-life of 100 days, right? The yellow is 10 days. And then this, I like this one. That's my favorite. What is that?
Very short.
Very short. Yeah, we just don't know. It's so short we don't even know, right? It's just unstable.
So that just means it's like a stone measurable thing that we can make it and then it goes away.
Yeah, it's, yeah, right.
Neon 20.